So today I'm going to talk about some pain points in cybersecurity and what are the key components with respect to the problem that we are trying to solve here at Versa, and why those things are important to solve. And predominantly I'll be focusing on ADP, DLP, and some of the AI ops stuff with respect to deployment, training, etc. And we'll head on to questions at the end. I'm pretty sure you guys will be eager to ask questions. Please feel free to interrupt me in between to ask questions. So the pain points today are related to how applications are deployed, right? So some applications deployed on-prem, a lot of network traffic going into the cloud. So at each point of attachment of an API, for example, you are trying to reach an API endpoint. So you are trying to secure the perimeter both from on-prem perspective, inline, as well as in the cloud. You are trying to even secure the API. So for each of these things, you have an attack surface, right? So the attack surface grows as the traffic traverses all these different endpoints and hops to all these endpoints. Your attack surface grows because that is where an attacker can inject himself. All right. So the other thing is that nowadays breaches are becoming very costly, right? So as we evidenced by the SolarWinds attack, wherein the attackers were able to hide for a long period of time until the malware payload is delivered by an update, right? And other one is a Microsoft breach that happened recently. So all of these now cost from millions to billions of dollars now, right? So there are so many security solutions at play because the attack surface is so large. For each of them, it needs a point security solution, right? So whether it be browser isolation, API security, trying to inject yourself so that in your Kubernetes clusters you have security within that perimeter, all of that. So a lot of these involve very complex deployments. Complex deployments involve complex configurations, and complex configurations means misconfigurations. So a lot of these data breaches are attributable to that, right? So you have nowadays with the advent of AI and especially ChatGPT, now that the genie's out of the bottle, we have all sorts of GPT-based or generative pre-trained transformer-based attack models like Worm GPT, Fraud GPT, all of these that are being created, and now attackers are using all of these pre-trained transformers to actually create models to generate the malware payloads faster. So the one thing that I would like you guys to take away from this topic of discussion is that data is paramount. That is everything. Even if you talk about models, what type of models, there are hundreds and hundreds of models now, right, of AI models. Data is the most important thing here. If you don't have good data, your models are useless. So yeah, what we are where Versa is coming from is that, okay, the data that we used to train on for creating all the models to identify malware or any data loss prevention mechanisms, the data has to be critical. So all of this is integrated into a unified data lake, wherein the data comes from omni-channel sources, not just from a single source, from multiple sources, even within our internal networks. So the two key things that I'm trying to talk about in this presentation is predominantly the advanced threat prevention, which is malware detection, which is part of the advanced threat prevention suite, and the data loss prevention, right? So the AML-based malware detection is it is deployed in multiple stages. That is why I've written it's multi-stage deployment, right? So it is multi-stage filtering in the sense that the model that is on-prem detects a certain set of malware. Then, if it is not able to detect at high confidence because it's a low latency model, then it will be sent over to the cloud, wherein a much higher level of analysis will happen on it with using different set of models, much more complex models. So it is a multi-stage pipeline for detecting malware in 90% of the predominant file types, right? Which are the predominant file types? Anybody? Show of hands. Exactly, right? So most of the malware is delivered using exe files. And how do you get to those exe files? There are other ways to get to those exe files, right? One is a loader, one is a JavaScript. You reach JavaScript and somehow you are able to get to the exe file, which is then deployed, right? So these are the main file types that we are focusing on at VersaONE. So going to data loss prevention, right? So data loss prevention is whether it be intentional, unintentional, malicious, it could be from a different, all different perspectives. From an enterprise standpoint, all of this is data loss prevention, data exfiltration, which you don't want to happen, right? So it's a chasing game, right? Wherein we are always trying to figure out that, okay, this is the data that we don't want to get out of the enterprise. This is the specific data, like the blueprints, file confidential files, etc., that need not or should not leave the network. So that is something we are focusing on. So, and I'll go into the details of this at a later point.
Yeah, I have a quick question.
Yeah.
So AIML-based data loss prevention doesn't really do away with the need to have EDMs and everything.
Of course not. Of course not.
It's on top of it.
Yes. Yes. So it's I'll go into more details later, but wherein what are the applications of AIML and why we are using that, right? So and then EDM, redaction, etc. All of that comes on top of that. So these are some of the salient features for our malware detection, right? So what are the file types? As I was just describing earlier, that these are the file types that we are looking at. These are the predominant ones because this is how most of the malware is delivered on the internet, right? So the PE, PDF, all the OLE files which are docx, PPTX, RTF, XLSX, and HTML JavaScript, right? So as you would observe that all of these are different file types with different characteristics, and how the malware is delivered is different for each of them, and how it shows up with respect to, for example, an exe will have certain sections within that. So if you've ever looked at an object dump of an exe file, you'll know that how the malware is delivered is you'll have it at a specific offset and it's loaded from that specific address, right? So in this case, you have PE files, exe files, PDF files which you'll have embedded either JavaScript streams or image files which might have encoder related issues which the attacker might be exploiting, or OLE files wherein you have classic VB script related exploits, right? And VB script, VBA stomping. So, and JavaScript. JavaScript is very important here because it's on the client side of at every browser, every page. So that is how the attackers mostly try to get to download the eventual exe or PowerShell script, whichever, for executing the malware on the system. Now, for each of them, the different distinct models are trained, which are like, it may be boosted trees, DNNs, or transformer models. So it all depends on the application. We have trained multiple models for each of them. It could be an ensemble of models as well. So what are we trying to achieve here, right? So we are trying to play catch up in this game, to always try to stay one step ahead of the attackers, right? So classic static analysis would be based on doing signature matching, right? Pattern matching, regex, PCRE, or writing YARA rules so that you can catch specific type of malware families, right? So we are trying to go one step beyond that, and we are trying to see if we can attach semantics to understanding how a malware behaves, a malware family behaves, so that we are able to catch zero-day attacks, right? Because if you would observe in the wild, a lot of this malware has been written long time back, but it's deployed even now, and we are not able to catch it, right? So that is, we are trying to make sure that we catch the zero-day malware, which is occurring with much more frequency now. So, and as far as deployment goes, it will be deployed as part of the ATP suite, which is the Advanced Threat Prevention suite, which is part of the Advanced Security Cloud in VersaONE, and it will be responsible for run as a microservice service within that, along with other sandboxing, etc. microservices. Any questions? Okay, let's move forward. So some of this I have already described earlier, so but let's go through it quickly. So what we are talking about is from static analysis to coming into AI/ML. We are going for proactive detection for catching zero-day and polymorphic malware, and trying to eliminate zero-day attacks for most of the file types, common file types that we see in the wild. So static analysis uses a lot of heuristic mechanisms, static analysis for PE, VBA, etc. files for trying to get attributes which might be attributable to or will provide hints regarding whether the file is malicious or not. In this, what we are trying to do with AI/ML is we are going one step further and we are trying to learn based on not just the hints but actual behavioral analysis of the malware itself. So threat remediation as well. Sort of, the faster you can detect the whether this is a malware with a certain degree of confidence, the faster remediation you can have. Because a lot of these the classic mechanisms focus on heuristic techniques, a lot of malware can slip through the cracks, and the remediation takes a long period of time with the red teams and everything coming in at a later point trying to figure out what is the problem, right? Or where did the attack start. The faster you can thwart the attack and detect it, which is what we are trying to do with the Versa AI solution, is that you can remediate those threats faster and much earlier because it's being deployed. Our AI solution for malware detection is going to be deployed in multiple points, as I will show later during the slides.
So the remediation does not happen, is it just out of the box, does it remediate, or
you can attach actions associated with that. So which will make sure that it doesn't proliferate because you're detecting it much faster.
is it going to be onto the client to be able to define those parameters, or
Yeah. So we will allow, as it's because it's part of the advanced threat prevention suite. So the configuration will dictate what you want to do with such kind of files, because you would determine that whether you want to block it or you want to allow it once, allow and scan. A lot of these things can be done.
True, but I guess my point is kind of more so on you're going to have a lot of false positives, right?
Possible, yeah.
And also, one of the things is, will Versa maybe in the future have some sort of like advanced ML AI threat detection team that can assist clients, or it's just all going to be on the client to be able to?
No, of course it is. So there has to be some at a certain point in time. There is entirely possible that there will be false positives, right? Because we are not nobody can guarantee 100%, right? So what will happen is that post-mortem, if there is some attack that went on and you were not able to, and it was a false negative in that case, right? So not a false positive. So in that case, we'll be able to help you trying to figure out, okay, what has happened, where did it start, where did the attack start, and we have our own sandboxing as well as multi-AV analysis. Sandboxing is a much more complex solution where it will be run through the sandbox, and we will try to figure out, okay, what is the actual behavioral analysis, and we have other cloud vendors as well whom we associate with who might be able to assist us in that. So all of that is into the post-mortem and which ties into the continuous training. So I'll show that later.
For the malware detection, does Versa develop its own malware signature database, or
there is no signature database. That is what. So that is the difference, right? So for the AI/ML case, there is no signature database. Yeah, it is a model which is trained based. Yeah. So that is why we are trying to get away from those static signatures, right? It will be there. It is part of the analysis, but we are also complementing that with AI. So yeah, let's talk about structured and unstructured. So if you have experience with AI, then you know that the different types of data that you deal with is structured as well as unstructured, right? So structured data is something you can look at it and make sense of it as a human. Unstructured data is something you are trying to make sense of it. It might be text, it might be garbled data, whatever, right? So and you can't make sense of that. And you can't find semantic relationships. Maybe you can in proper pure text data, you can, but in other type of data, you might not be in plain sight make sense of that. So what we are trying to do is that we are segregating these into structured as well as unstructured analysis, right? So in the structured case, let's what we'll do is that and we'll have a repository of files, right? This repository of files comes from multiple sources, multiple vendors, reputed vendors, as well as from our internal mechanisms, right? Dog food. So we will try to extract all possible features, right? And because this is a huge repository of data, millions up to billions of files, right? You cannot train on such a huge set of files. So what we try to do is that we try to have our own clustering mechanisms and other classic ML techniques that we use to actually whittle down what are the indicators, which are the files that we should be training on, which are the important features, etc. And we try to figure out, okay, these are the set of files we down select to actually train on. Right? So from millions, from almost close to a billion files, you will be able to whittle it down to a few million files that we train on. And so we try to subsample so that we try to make sure the model for a given file type is as generic as possible. So we will generate multiple AI models in this process. So I'll go through this a little faster. So multiple AI models are generated to figure out, okay, which is a model which works in this particular context. In some cases, you cannot have a silver bullet for each case. Some cases might require multiple models. So ensemble models are created in those cases wherein we are trained, multiple models are trained, and then you will actually figure out, okay, these two models in conjunction may give us a much better accuracy in recall value than in just having one model, because some of the features are caught by certain model, some other features are caught by some other model, right? So then we rate all the models that we create. So as I had said earlier, there are different type rating, boosted trees, classic ML techniques. We are not getting rid of any of the classic ML techniques because they are useful to solve certain point problems and they solve it very fast. We get like less than a second latency on those models. So you cannot get rid of those kind of models. LLMs we of course have, but those are much slower. So those will come from more complex models. So create an ensemble of models for the use case, and of course, in ML AI world, there is if you are not tracking your models, you should shut shop. So you have to track your models. The performance of models over time is the most important metric of whether you're doing the right thing or not. I think Apurva alluded to this in the morning. It's the same. I'm reiterating that. That is the most after data. Tracking it is the most important thing. Model generation, yes, model creation, all of that is important, but these two are very, very important.
So for your LLMs, how often are the models being trained?
Models are being trained depending on how many files we ingest, right? We have a threshold, okay, if we hit these many cluster of files, then we train. So sometimes it could be a couple of weeks, 3 weeks, depending on how much data we ingest of a specific type, right, of a specific file. So if there are multiple clusters that we are able to find within that multiple malware families, then we will train on that immediately. Otherwise, we'll have it as slightly large, because training is important, but comparing metrics is also very, very important. So let's go to the unstructured part, right? So this is more on the LLM side. So as I said earlier, those are structured works for classic cases. It works very well, and we of course for all the streams of data that is generated from individual files such as PDF files, right? You have a JavaScript which will be embedded within a PDF. There will be VB script which will be embedded within OLE files, which will be used to run macros, right? So and there will be JavaScript independently embedded within HTML. Right, so all of these, let's say you have a specific type of malware, that is, let's say a coin miner or a coin hive, right? So these are malware which hides very well within a huge JavaScript file, and the eventual goal is to turn your computer or your host system into a Bitcoin mining system, right? So you're trying to find out within such a huge JavaScript file, trying to find out what is the malware family. You are trying to cluster and classify the malware family, as well as trying to determine whether it is malicious or not. So for all of those, semantic analysis or semantic understanding of the code is very, very important, and that is where LLMs comes in, right? So that is one example. So same, this rest of the stuff is the same. The only part additionally that we need to do is optimize LLM for inference, right? Because training, you can be as slow as you want, everything is good, you can push it to a GPU cloud and let it train. But you have to optimize your LLM for inference, because what happens is that, let's say you're deploying this on-prem, you cannot have extra very large overhead with respect to latency, right? So that is also very, very critical, performance critical. So we optimize our LLMs for inference. So so that the LLMs are much smaller when deployed on-prem.
Are you able to kind of offer like some sort of like project instances?
That we can probably talk about that later. Right now it's in our ADB cloud, but yeah, we might be able to do that. This is the same thing, update metrics. So consumption strategies are two. One is a cloud consumption strategy, which is where it is deployed within our ATP suite, and it will be accessed from multiple origins. I will go to that a little later during the AI ops part. But here, it will be deployed as a microservice as part of the ATP suite, and as well as AI scanner library within the on-prem instance. So an on-prem instance will have regular model updates as part of the SPAC. So these are the two classic strategies for deployment. So this is a snapshot of how it looks when analytics captures one of the malicious files. So I'll talk shortly about DLP as well. Data loss prevention can be is for different kinds of document types, right? So you want to make sure that your data is not exfiltrated out, either in forms wherein a document is embedded within a document is embedded within a document, right? So it is all of those complex strategies for exfiltration of data you should be able to detect. So you could have it in text format, PDF, doc, images, etc. So the first and most important thing is to pre-process the data to make sure that all the data that is embedded, or let's say within a given document there are images, text, and other documents that are embedded within a given file, all of that is extracted out, and you pre-process that data for training and inference, right? And for determining what or classifying the data first, to detect what type of cluster this belongs to, whether it's a type of credit card, source code, passport or schematics or whatever. All of the multimodal content is extracted out for classification, and eventually it is given out to the fine-tuned LLM, which is used for classification. So please note that we use multiple different models here as well, not just LLM for classification. We'll use CNNs. We'll use NER models as well for classification. Those are much faster, but their scope is limited. For more complex applications, we still use LLMs. So model training is the same. So you have to ingest data from multiple sources, but here there is a slight difference, right? Some of the data for the ETL part for a given model is different from malware. Right, so here you have to clean, normalize, upscale. So for if you take an image, right, normalization, upscaling, augmentation, synthesizing, all of that are critical components for DLP. Because without that, a model will not be able to, an LLM cannot actually, you'll be able to train on that. So because let's say converting into grayscale and all of that, so normalization and cleanup of a given document and image is very, very important. So you'll train all these multiple models as I talked about, embedding models, CNN-based classifiers, NER models, transformer models. And pretty much the same steps apply here, you can connect the dots. So the idea is to have a unified framework for AI ops, training and deployment. So why do we want to do AI-based DLP, right? So we have classic methods, but classic methods fail in certain cases wherein you are using very limited context for matching of certain signatures, regex, etc. All of those fail. So in those cases, contextual analysis is very, very important. Let's say you have if you look at any particular statement within a text, it might not be sensitive in and of itself. But multiple statements in different paragraphs would allude to some sensitive information being divulged. So that kind of contextual, temporal and spatial contextual information that needs to be maintained can only be gathered by some model which can actually do semantic analysis. And that is pretty much a transformer model, right? So, and the larger parameter models have much better semantic understanding. So static detection techniques, as I just talked about, will be like unique hash, regex for pattern matching, keyword matching, classification tagging that is typically used for traditional DLP. What we at Versa are trying to do is that trying to go a bit step further, right? So we will always be using the classical techniques as well, in conjunction with the AIML techniques that we are developing currently, right? Or it's going to be productized soon. So, what we'll try to do is that we'll monitor as well as retrain all of our models as and when we see new data coming, right, from different omni-channel sources. So, all the anomaly detection, as you would see here, as well as in the parallel session that's going on, the anomaly detection mechanisms within AI, using AI/ML methods, is far better than classical mechanisms. And the same applies here as well for detection of sensitive information and unstructured data. So AI ops part, right? So the ops part is very important to note here. So wherein you are ingesting data from all these different type of sources, right? So we have, from a Versa deployment point of view, we have a Versa branch, an API-DB cloud, a SASE gateway, and RPI service. All of them for malware detection will reach out to the ATP suite, and AIML is part of that ATP suite. So we have all of these will reach out to our microservice mesh here, which is KH based, and we have the auth service, which will provide appropriate AAA, managed AAA, as well as a file submission and result notification service, which will handle file ingress and egress, resulting in egress. And we have these two microservices which will be deployed within this, so as to form the AIML backbone. And these are the database and event-driven service integration, which are used for communication between the services as well as data storage. This is our next step. This part of the training for ADP and DLP. So most of this stuff will remain the same. So the data feed for multi-vendor data feed goes into the model training pipeline. So model training pipeline will be either can be deployed KH based, and there will be associated tracking dashboard. The tracking dashboard will track all the metrics, hyperparameters, features, data sets, all of that version along with the model, so that we are able to track that, okay, this model, whenever there was a false positive, false negative, which was seen at some point in time, we can track back to what model, what data set, what set of features were used at that point in time, right? So that is why the need for tracking. Here the same thing happens. So we have the data ingestion that happens at this point from omnichannel sources, and whatever data is ingested is pre-processed and used for model inference. So after model inference, there will be a model inference dashboard as well, so which will track metrics from model inference. So all the metrics today, after inference, it will give you a JSON dump of what is the model, what is the data set, what version, what is the type of a model, etc. All of that information we will be tracking. So as you can see, this will be fed back into all the omnichannel sources are also fed back into the continuous model training pipeline. So insights are generated from the inference dashboard, which is a result notification service, as I said earlier, mentioned earlier, will be relaying it out to all the clients. And finally, once the post-mortem analysis is done, we'll be able to feed back that into the continuous model training pipeline. So this forms pretty much the AI backbone, AI ops backbone. Any questions? That's all I have.
Any questions?
We have one.
I can speak loudly enough. So, for the DLP part of it, yeah, for the DLP part of it, right? So when you get the data synchronously, somewhere in today's morning's presentation, he said we'll get a copy of that email or whatever. And later on, I'm talking about the sovereign, SASE and other things. How do you secure that data that you gathered from, that you shouldn't have it? Because at this point in time, you got a copy of something that you should want it, right?
All right. So in this case, though, it is not like dependent on the customer's the configuration, right? So if the customer doesn't want us to store any data persistently, we will not be storing that data persistently. So it is all dependent on the customer configuration. So if the customer allows us that, like trust Versa to actually, we'll ask you that we will anonymize that data for training or for doing postmortem, right? So then you can give us that data and we will be using that. Otherwise, you can say, okay, we cannot give you that data. It has to be within our data lake. Then we will not be using it.
Thank you.
I think the default is 98.
Okay.
Jim, did you want to cover how we are planning to use GPUs and?
Oh yeah. Yeah. Let's get to. So I forgot to mention it as part of that. So for the training part, right? So what we use is currently a GPU cloud. So we had been using GCP, Vertex, as well as depending on. So we have a bidding system, etc. All of that set up so as to be able to use whichever GPU cloud is available, which just gives us the best bang for the buck, right? So that is what we use for training part. Now for the deployment part, the clusters that we use for on-prem, right? So on-prem there will be a cluster, the whole pool of on-prem servers which will be used for the entire ATP suite. Within that will be a pool of servers which will be GPU clusters, which will be used for inference. Now, on-prem, we are planning to also include on-prem in the sense that for the gateways, we are planning to add GPUs there so that inference can be done even at that point. So so we are exploring a lot of these alternatives, or rather, in the process of doing this with NVIDIA as our partner.
What about the TensorFlow and all of that?
So one that is also in the works with Intel. We are actually working with Intel to actually use Sapphire Rapids and other newer chips that they are coming out with, so as to use that AMX instruction. If you don't know what AMX is, the advanced matrix multiplication instructions that Intel has, as well as an AMX and tensor block within their newer processors. So we are trying to use that for inference as well.
From a roadmap standpoint, where are you in being able to demonstrate this?
So ATP is going to be released like as we speak, right? So DLP is coming second half. Yeah.
On the training, how constant or continuous is it?
So that is what I think I answered part of that. So what happens is that we have data ingestion from multiple sources, right? So we will get continuous streams of data, and we will update our database, and so we have a pipeline which takes data from there, does clustering and all the other analysis to actually figure out whether this data is disparate. We have enough disparate malware families or clusters that we can see so as to be able to train on it. See, when you're training model, it is very, very important to ensure that you eliminate biases. Bias elimination, overfitting, is the key to creating a model. So as I said earlier, the key takeaway, if you want to take anything from this presentation, is data is key and metrics is key. Yeah.
I guess my last question on the issue of privacy, right? Because I think that one is going to be a major issue.
Yeah.
How's Versa going to try to circumvent that? Because I'm pretty sure you're probably going to get a lot of resistance, and because the nature of data that's coming through some of these pipelines has to have some sort of like.
Yeah, so that's why it is always customer dependent, right? So because we have so many customers, a lot of customers will be hesitant to actually give us any of their data or keep any of their data in our cloud, right? So for that, we are exploring on-prem solutions, and which we will deploy on-prem into their network. So they can say that, okay, this is our specification, this is what we want, and we will tailor it to their specific needs. So we are working towards that. I think we have few customers who already asked this question. So, but there are some customers who are okay with us working with their data because they trust Versa with their data. So we'll work with them to identify what all data can be used for training and all of that.
So, but then on the private, on the on-prem instances, will the customer have to have their own LLMs, or?
No, it will be our LLMs deployed there in the cluster.
Okay.
But we will specify what, if, like, depending on their requirements, we will specify what kind of hardware to get, what kind of cluster to deploy, etc. All of that.
The security models are universal, so even though we kind of test the model on our data, it will apply to our customers too. That's not true for networking models, because they're very bespoke to customers.
Any other questions?
Thank you.
Yeah, thank you.